When we zoom out of the Milky Way, we are met with an incredible sight. All around us, stretching as far as we can see, are countless other galaxies, each similar to our own, yet also unique in their own right. And yet beyond them, it seems like there is nothing at all. So what actually happens if we keep zooming out? What does lie at the edge of the observable universe? To find out, let's take a journey through space and time unlike any other. All of the objects we can see in the night sky are incredibly distant. Even the moon is over 384,000 kilometers from Earth because light takes time to travel. When we look up into the night sky, we're actually seeing things as they were in the past. The further away an object is, the further back in time we are seeing it. When we look at the moon, for instance, we're seeing it as it was about a second ago. But when we look at more distant objects, we're seeing them as they were thousands, millions, or even billions of years ago. The most distant objects we've ever seen are the galaxies that existed only a few 100 million years after the Big Bang. And the further away a galaxy is, the faster it is receding from us. This is because the universe is expanding. Galaxies aren't just moving away from us because they're being pulled along by their local group, which is also moving away from other groups of galaxies. They are truly expanding, stretching, and warping space itself. And the further away a galaxy is, the faster it is receding from us, because more space is being stretched between us and them. And so if we were to zoom out further than the galaxies that we currently see, we would be able to see back further in time. We would see them as they were in the very early stages of the universe, and if we were to keep zooming out, eventually we would reach the edge of the observable universe, the furthest point in space and time that we can currently see. At this point, it would appear as though we had reached the end of the universe. Nothing could be seen beyond it. There would be no new galaxies, stars, or planets. But what would actually be happening? What if we were to build a rocket ship capable of traveling at near light speed? And then instead of zooming out with our eyes, we would zoom out in person. If we were to do that, we would quickly realize that the night sky is not actually filled with stars. The ones that are closest to us are part of our galaxy, the Milky Way, but there are also stars that belong to other galaxies that are close enough to us to be visible under a powerful telescope. These are the stars in the local group of galaxies. There are around 50 or so galaxies in the local group, ranging in size from dwarf galaxies with only a few million stars to giants like the Milky Way and Andromeda, which is almost twice as many stars as we do. Most of these galaxies are irregular or spiral-shaped, but some are elliptical. Elliptical galaxies tend to be older and contain mostly old stars. They also have very little gas and dust, whereas spiral galaxies are much more active places with lots of star formation going on. The Milky Way is thought to be a spiral galaxy. However, because we are inside it, we can only see one side of the spiral structure. In reality, it looks more like a flat pancake with a bulge in the middle and long spiral arms extending outwards. Our solar system lies in the Orion Arm, a minor spiral arm about 2/3 of the way out from the center of the galaxy. It takes our solar system about 225 million years to complete one orbit around the center of the galaxy. As we move further away from the center of the Milky Way, the number of stars in the night sky would begin to decrease until it is so dark that we could barely make out the shapes of the constellations we are familiar with. Eventually, we would leave the Milky Way behind and enter the depths of intergalactic space. We might think of space as being empty, but in reality there is a lot more matter out there than we realize. Most of it is in the form of gas and dust that fills the space between the galaxies. This is called the intergalactic medium, and it is surprisingly dense. A cubic meter of this material weighs about 100 kilograms. If you've ever seen a nebula, then you've seen the intergalactic medium in action. Nebulae are giant clouds of gas and dust that often have a beautiful array of colors. They are usually found around young stars where the material is being pooled in to form planets. The famous Orion Nebula, for example, is about 1,300 light-years from Earth and contains a cluster of hot young stars. As we continue our journey, we will begin to notice that the background is changing. Instead of the black void of space, we now see the light from billions of galaxies, all of which are also made up of billions of stars. We are now seeing back in time to the early universe. As we go further and further back in time, the galaxies we see become smaller and more numerous. This is because the universe was much more dense in the past. There were simply more galaxies packed into a smaller space. We will also notice that the light from these galaxies is redder than the light from the galaxies closer to us. This is because the universe is expanding. As the universe expands, the wavelength of light is stretched, shifting it towards the red end of the spectrum. The farther away a galaxy is, the faster it is receding from us and the more redshifted its light will be. The most distant galaxies we have ever seen are those whose light has been redshifted so much that it is now invisible to our telescopes. These are the galaxies that existed only a few 100 million years after the Big Bang. They are so far away that it would take light more than 13.7 billion years to reach us, and thus we see them as they were in the very early stages of the universe. At this point, we have reached the edge of the observable universe. Beyond this point, we know that space continues, but we can't see it. It's like standing at the edge of a cliff and knowing that there is more land beyond the horizon, but we can't see it because the ground hides it from view. In the same way, there is more universe beyond the observable universe, but we can't see it because the light hasn't had enough time to reach us yet. If we were to somehow get beyond the edge of the observable universe, what would we see? The answer is that we wouldn't see anything. There wouldn't be any galaxies, stars, or planets. It would be completely dark. That's because there isn't enough matter beyond the observable universe to make anything like that. Everything in the universe is made of matter, and all the matter in the universe is inside the galaxies. Once we got beyond the edge of the observable universe, we would be in a region of space that has never had enough matter in it to make anything like that. It would be a truly empty place, a place where nothing ever happened and where nothing ever will happen. This might seem surprising, but it makes sense if we think about it. The Big Bang Theory tells us that the universe began with a hot, dense singularity. Everything in the universe was packed together so tightly that it was impossible for anything to exist. Then the universe began to expand. As the universe expanded, everything spread out. As it spread out, it cooled. As it cooled, matter began to form. That matter eventually formed into the galaxies we see today. If there wasn't enough matter in a particular region of space, then nothing could ever happen there. It would always remain empty. So if we were to get beyond the edge of the observable universe, we would see nothing but emptiness. It would be a truly humbling experience. We would realize just how small and insignificant we are in the grand scheme of things. But it would also be an incredible opportunity to learn more about the universe. By studying the emptiness, we might be able to learn more about the Big Bang and how the universe began. We might also be able to learn more about the nature of reality itself. After all, the observable universe is all that we can currently see, but that doesn't mean that it is all that there is. There may be more universes beyond ours, and studying the emptiness may help us to find them. If you liked this video, check out another one where we talk about whether or not there is a planet in our solar system that is suitable for life. Or check out another one where we talk about what happens to your body after you die. Thanks for watching.